Hello, everybody. We're about to get started on this webinar about the Atlas II HSS Connections Hub. Really appreciate everyone taking the time to be here. This webinar was sent out to existing people who've signed up for the hub. So all of you are users, whether you just signed up to take a look or you've been using it for a lot of connections already. So certainly, a group that already is informed about it, but we're hoping that we can give you a little bit more information and make it that much easier to use and that much more productive a tool for what we're doing. Before we get started, we would be interested to hear if you've already been using the hub on any projects. We'd love to hear about what you've been using it for, so feel free to put that info in the chat, and we will get started. So let me go ahead and put my screen up here, and we'll get into it. All right. So again, this is going to be a webinar on the HSS Connections Hub, but we'll start off with just a little bit general information about Atlas II. First of all, maybe about myself. I'm Ted Goldstein. I'm a structural engineer with Atlas II. I was also the developer of the Shuriken, and I manage that product line. We'll cover that very briefly, but today is really about connection design with HSS. Very briefly about Atlas II. We are the largest producer of HSS in North America, and we produce the largest HSS. Aside from that, also a lot of pipe piles, which we're not really going to touch on today. That's more of a geotechnical thing. And then we also have the Shuriken, which you see down there at the right, which we'll just very briefly mention, and which actually shows up in a number of connections within the HSS Connection Hub. We're very proud that we are, a domestic manufacturer. All of these jumbo sizes and the other material we provide are all produced here in the US. Or for those joining from Canada, we do have one plant in Canada. So we want to make it easier for people to use this material, and that's what we're going to cover today. Again, I mentioned we produce the largest HSS. What that works out to is squares up to 22 inches, rectangles up to 34 by 10, and rounds up to 28 inches. And all of those we can do with a 1-inch thick wall. The reason that those particular sizes are selected as the top end of the range is that's the largest you can do under the A500 or A1085 specifications. So basically, if the material can be produced according to that spec, we produce it. We invest a lot in technology to allow our mills to be flexible, to switch between sizes quickly. That lets us produce each size more frequently, and that means that they're going to be generally more available. We can also do very long lengths. We've done up to 135 feet, which was fun. We had to poke a hole in the side of our building to get those pieces to come off the production line. But if that's something that your project required, that is a capability we have. One of the things talking about sizes here and availability that I do want to highlight, it's one of our most used resources. So I just want to spend a minute here is our HSS availability charts. So we want to make sure that anytime an engineer is speccing a product, that they have the information that's going to be helpful in terms of making sure that that's available when it comes time to actually do construction. So if you go into those the availability chart, which is on our website, basically it's a color-coded resource that's going to tell you what are the sizes that we're producing most often, which are shown in green here, the sizes we're producing reasonably frequently in yellow, and then the ones that we can produce but are less common, so often require custom order. This is an Atlas II specific resource, but we're responding to the same market forces as any other producer of HSS material. So in general, it's a very good guideline for what sizes are easily available versus those where a little more care has to be taken to just ensure that you're going to have that availability when it comes time to actually start construction. And I did mention the jumbo HSS. So, in the availability chart, basically the jumbo HSS are those sizes there in the bottom right, which are either larger, thicker, or both compared to what's typically available on the market. The other product, which I mentioned earlier, is the Shuriken. This is actually kind of my baby, so cutting it down to 3 slides was very difficult for me, but if you do find it interesting and would like to have a presentation for your firm on the Shuriken itself, certainly let us know. We're happy to set that up. But basically, again, another tool that we came out that we have to make it easier to work with HSS. So the hub, the Connections Hub that we're going to talk about today is mainly about doing the actual design for HSS Connections. The Shuriken is about the physical process of connecting pieces. It's essentially a single-use wrench that holds a nut in place. So you can kind of see on the right where they would be installed on splice plates if you're doing, say, an HSS column splice. And what that means is when you get to the field and it's time to actually bolt things together, you're going to have that nut on the inside letting you install the bolt from one side. So basically the idea is to take some of the more historically difficult connections which have required welding in the field and turn them into bolted connections. And again, there are a number of different calculators within the Connections Hub that make use of the Shuriken to allow for field bolted connections with HSS. It works for both snug tight applications. In that case, you just need the bolt itself, no washers required by code. Or if you have a pretensioned or slip critical application, you can do that as well. But we do strongly recommend using DTI washers as the method to verify the pretension, since that can be done entirely from the exterior where it's going to be visible. So there are, initially we came out with the Shuriken mainly for column splices, but it's come to our attention, thanks to the creativity of the engineering community, really, that there's a lot of other ways that you can use it. So we've gone ahead and put together some resources. These are on our website. I'm not really going to go into any detail today, but just want to make you aware that this resource is out there, in terms of different ways that it can help you simplify your connections, and that really it's just a matter of how creative you want to be with it. So I'll leave that there, and we'll go ahead and get into the real meat of today's presentation, which is about the HSS Connections Hub. So what is it to start? The Connections Hub is really about supporting engineers, making it easier to do what you have to do for your projects. So that includes a few things. First of all, typical connection details. Essentially, those are going to act or you can use them in the way that you would any other typical detail library your firm might have. Then there are the calculators. We'll spend quite a bit of the time today talking about those calculators and how to interact with them, how to make the most from the capabilities they offer. And then there's also design and technical support. There are ways to get in touch with us through the hub if you have project-specific questions or calculator-specific questions. We want you to do that. We want to know what are the challenges you're facing and how we can help to make that to make them simpler. Before I get into the mechanics of the hub specifically, I want to zoom out a little bit and kind of talk about why we started this project in the first place. It's no surprise that we think that HSS is not used as often as it probably deserves to be, given the really great properties when it comes to compression and that sort of thing. For what it's worth, I'm kind of a true believer on this front. I worked on developing Shuriken to make HSS easier to use before joining Atlas. So even before I was an Atlas employee, I really thought that HSS was a product that people should be using more of. And so the question is, why is it so comparatively rare, compared to wide flange in the engineering and construction world? And at the base of it really is we have kind of a chicken and egg problem. Wide flanges, or even 4 wide flanges, built up I-shaped members have been around for well over 100 years. There's a huge amount of experience and precedent and research that has gone into using them. And so, it's not surprising with HSS having been a much more recent development that there's less experience in the engineering community. And, in a profession where we, obviously, of course, we go to school, we learn the basics of mechanics and all that, but so much of our engineering education happens in the form of experience. So when you have a product that is less common in the market, of course, you're going to have less experience. And that means when it comes time to actually go ahead and use that product in a project, there's a good chance you may end up with designs that are less efficient. That's not a criticism of anyone. It's just, again, how we learn as engineers, and the side effect of HSS being less common in general. And so if you do have a less efficient design, the result that we tend to see is we tend to get high fabrication costs. If an engineer has a detail on a drawing that's difficult to build, it's going to be more costly. And of course, if it gets the reputation of being more costly, it's going to be less common, and the cycle kind of continues. To a certain extent, Shuriken was an effort to kind of stop this cycle, and the HSS Connections Hub is a much more dramatic effort to make it easier to use, and not only to be a tool that allows you to, produce a specific design for a specific project, but also one that improves familiarity and gets people more comfortable with using the material. Quick example of that. This is a slide that I've taken from some of the other presentations I've done talking about shear connections to HSS. So, often we will, if we go to an engineering firm and look at the typical details, it's very common to see the through plate as the typical connection beam to HSS column connection. And the reason for that is, I think in a lot of cases, people are just not aware that really you can generally use all of the other easier to produce connection types. So on the right, starting at the single plate at the top, which is the most economical connection, single angle, double angle seats. These are all options, and generally speaking, you can pull them through from the AISC manual. What we really want to tell people is avoid through plates. They are hard to produce, and that contributes again to that tendency for fabrication costs to be higher with HSS than like flange in some case. So again, really trying to get that message across, but this is just one example. One of the important things I think we need to mention is it's designed by engineers. We're working with a company called ClearCalcs, who specialize in structural calculators for engineers. And so this is, engineers designing calculators, not software companies trying to figure out engineering, right? So it has that background. The idea, again, we want to save time, of course. We want to optimize, help you make your connections more efficient, and make it really easy to do it. So there are tools to be able to share calculations within a team, within a project team, and just in general, streamline the process that an engineer has when doing this kind of connection. Starting to drill down what's included in the HSS Connection Hub, I'm going to take kind of the simpler thing first, which is the typical connection details. So often in engineering firms, and certainly this was true of the firms that I worked at before coming to Atlas, which were excellent places to work with a lot of great engineers, but I think it's a pretty common situation that typical detail libraries don't get quite the attention that they often deserve. They're used very frequently, but when you have project deadlines, going through your typical detail library and reviewing things to see what's really necessary, what's overly specific, what maybe has changed with recent codes, it's just tends not to be a high priority. And the result is that a lot of firms have detail libraries that are either outdated or often contain details that were really kind of specific to a project and were copied in, and you'll often have quite specific requirements which maybe don't really belong on a typical detail. And so our goal here is to really create a set that lots of engineering firms can use and be confident that what they're showing on those typical details is going to be kind of fabricator friendly, efficient from a load transfer standpoint, and that it's up to date with the latest codes and standards. These are all available in PDF, CAD, and Revit formats. You can get the full sheet in PDF, or in all the formats you can get single details. And the idea there is just if you want to get it onto your drawings, you should be able to copy and paste and just make a few little tweaks to make it specific to your project. But we want to make the process as seamless as possible. And again, of course, every firm is going to have their own standards, but we would love if these connection details could become companions to those firms. typical detail libraries. The other part of the Connections Hub is the calculators. So basically, it's going to let you go through step by step, obviously entering your geometry, your loads, your inputs, going through all of the steps in the calculation, making sure everything is clear. The code references are all very accessible and easy to understand. Also have a reporting function so that if you do need to submit the calculation, whether that's for internal review or possibly review by an agency, if you're working in the public sector, that again, just trying to streamline that process and make it simple. Again, you can share these calculations between people if you have multiple people working on a project, and we want to be as accessible as possible when it comes to giving support for these. With that, let's look at the typical details in just a little bit more detail here, no pun intended. So we do have the downloadable files. Right now you're seeing the first 3 sheets. At the moment there are 4 full sheets of typical details, all focused on beam to column connections. These, along with the calculators, are set to grow dramatically in the next few months. We'll probably hit 8 to 10 sheets once it's done. And the goal is to not only cover the beam connections, but also braces, base plates, splices, truss connections, etc. So really trying to make it a a thorough resource for really any of the common connection types that you see when working with HSS. I'm going to go ahead and pull up now just one, rather than the whole sheet, one detail specific one, just to see things a little more closely. And again, this is going to be available, or it is available in CAD and Revit format. So if you do decide that this is the way you want to go, you could just download that CAD file or that Revit file and drop it straight into your drawings. But one of the other points I want to highlight is that, again, the HSS Connections Hub is there to be a tool that's going to help you produce designs, and get through projects. But it also is there to be an educational tool. So with all of these details, we have engineering notes shown here in blue, which are basically going to give you some guidance. When is this an appropriate connection to use? So in this case, this is the most economical HSS column shear connection. And then perhaps some limitations. You can see note number 2 there, situations where maybe it's not applicable. We've also got references where you're going to be able to find information on these connections in the manual or in the spec. And then for the connections where they exist publicly, it'll also point you towards some design examples. So we want to make it easy to use, but also build that experience and that knowledge on the topic while we're doing it. So then, of course, the other big part of the hub is the connection calculators. Here, just a few screenshots, shows the interface very generally. We're going to dig into that interface in more detail as we go on here. But the idea, again, make it fast, make it easy to get everything in there, to see what the results are and to modify them as necessary. Again, you've got the reporting feature, so once you have everything done and you've got your utilizations are where you want them to be, you can go ahead and produce a report to convey that information to whoever needs to see it. And right now, again, similar to the details, we've got 20 connections on there, of which 18 of them are beam to column connections. And so primarily what we have now, shear connections and moment connections, and we have them both for wide flange beams connecting to HSS columns, which is very common because, of course, HSS are really, column application is really where they shine the most. There are certainly other applications, but that closed balance shape works excellent in compression, so that's where we kind of started. And then there are also connections currently that do HSS beams to either HSS or wide flange columns. Shown below on the left here in the bullet points, there are a couple other connection types. I'm showing them in gray because they are not out publicly yet, but we are moving very fast. To include those, we've got truss connections, so your TYKX connections, splices, both bolted and welded, base plates, and some other content as well. I think also I should include brace frame connections there. So we're moving fast. The idea is to have these out. We're not talking about filling this out over the course of years. We're talking about doing it over the course of months. So these are coming soon. So with that, I'm going to start to really get into the meat of the interface and how we interact with these calculations. Of course, everyone who's here today got the invite because they have gone on and created a username for the hub. Now, whether that's you just created the username and maybe played around with a connection or two, or whether you've been using it for actual work on projects, hopefully it still doesn't hurt to have a run through of all these features, and hopefully you guys come away with a little extra knowledge to be able to use the tools, to the best of their potential. So when you open it up, after you're in, you're going to come to this this project screen. First of all, one thing to mention, you can put your firm's logo in there. So while it'll show up on the screen while you're doing the calculations, but more importantly, it'll also show up in the reports that you produce. So if you are going to go ahead and submit those will be professionally branded to show your firm's identity rather than the Atlas identity. Then of course projects. That's where we are now. We can create a new project and to hold the various calculations out there on the right. And then we have the details library, which we've discussed. So there you can download individual details or the entire sheets in all the various formats. There are also ways to access those through the calculators themselves, which we'll look at in a couple minutes. And then down at the bottom, we have the settings, add your team. Most of this has to do with collaboration. That stuff is pretty self-explanatory, so I'm not really going to show it here, but it is something to be aware of. Those collaboration tools are quite useful if you're doing something, a project large enough that you have multiple people who may need to access things. So with that, once you've got your project set up, we get to this screen where we can go ahead and actually start putting in our calculations. Now, I have a few calculators that I've already got there towards the bottom, but of course we have, in red, the button Add New Calculation. I think that's pretty straightforward. Before we look at that, just one thing to highlight, that you can also group calculations. So if you wanted to group all your beam connections together or all your splices, you could do that, or by their location in the building, whatever way is most straightforward to you to organize them. Of course, that's a helpful option if you do have a large project with a lot of connections on it. So when we do hit Add New Calculation, it's going to bring up this screen for us to choose the connection type. And I mentioned we had 20 calculators, but we only see 6 buttons here. So basically what's going on is we're taking several of those calculators are going to be grouped based on the general concept. So what are we connecting and what are we connecting it to? So we have, if we click wide flange to HSS shear connection, all of these are wide flange beams connecting to an HSS column. It's just how we're going about doing it. Before we jump into one of these connections, I do want to highlight, as I was kind of mentioning earlier, that the goal here, of course, it's a tool to produce calculations, but we also wanted to have kind of an educational or an informative aspect to it. So if we look back at that graphic that I had shown earlier with the different types of shear connections and gradient of economy there, you're going to see a similar pattern here, right? So single plate is the simplest. It's all the way at the left with those options, and then gradually moving through to the through plate at the right, which certainly is an option. It has its time and place, but we want to avoid using it unless it's really required based on the forces we have. So in this case, we're going to go ahead and do a single plate calculation just because that's reasonably simple. There aren't too many limit states, and so the screen is not going to get too crazy as we go through this. But the processes, the things I'm going to highlight, would be the same regardless of the connection type. When you go ahead and you select the type of connection you want to do, this little screen will pop up on the right side of your screen. A few things here to point out. Of course, you can change the name of the calculation, whatever it needs to be. Another thing is when it comes to viewing the actual content, there are 2 views here, a standard view and a detailed view. The standard view is going to show the most important information, but it's going to take out some of the very things that are unlikely that you'll need to look at over the course of the calculation. So for example, if you're in the standard view, it may not show every single number about the column's cross-sectional properties. Detailed view shows every single number that gets used in the calculation. Personally, I tend to prefer the detailed view. I don't really mind having more stuff on the screen, but it is an option that's there. And if you're ever finding yourself wondering where a particular piece of information is, you may want to just check that you are in fact on the detailed view. If you're on the standard, it's possible that it's just been kind of edited out for brevity. The other thing you'll see here is for every calculation, it's going to show us the reference. Currently, all of the calculations on the site are referenced to AASC 360, but we do, as part of our plans to build this out, expect to have calculations conforming to the Canadian code in the next few months as well. So something to keep an eye out for those of you working in Canada. So once you get that all resolved and you close that little window, you'll be looking at the main calculation interface here. Again, just going to kind of go through and point out some things to be aware of. So right away at the top, we have all of our limit states, and on the very right, whichever one of those limit states is governing. Currently, there's one kip of live and one kip of dead load here, so all these numbers are very low in terms of utilization, but we'll see how that changes in a moment. All of those limit states are then repeated down in the bottom right, and you can see that all of those have little drop downs that you can click on to get a little more information about where those limit states come from. Even that is kind of a summary, and we'll see where you can find the nitty-gritty information as we progress. Some other things to highlight. First of all, on the top left, this is really the key properties is what they're called, because these are the most important pieces of information that you're going to have to input. Before we get into anything specific, one thing I really want to highlight is if you look up here, the second line is type of connection. So when we started that connection, we had that kind of menu of different shear connections that we could make: a single plate, a single angle, a double angle. That's changeable within the calculation. And so that's nice, because if you put in all your information, your member sizes, your loads, and you start to manipulate the configuration, if you can't quite get it to work, let's say as a single plate, whether it's just because the load is too high or because maybe you have a column with a slender wall, you can go ahead and use that dropdown to change to a different connection type, but you'll retain the information that you've already entered. So you're not going to have to kind of give up and start again from scratch. All of that is still usable, and just, again, another way to try to streamline the process here. And of course, in that section, going back just a sec, I mean, you've got all the basic things. You've got your beam section, your column section. For simplicity, I've just kept the default options for those. But certainly any wide flange beam and any HSS column that's in the manual will be available here. So once you get through those key inputs, one other thing to highlight, we do have the diagram on the right here. This is live, which we think is very important. So if you change the number of bolts from 3 to 4, you'll see that change on the diagram. If you change edge distances, you'll see that as well, member sizes, etc. That's really important because, when we're doing engineering, of course, the numbers are very important. You have to get them right, but intuition and judgment matter too. And so by having the diagram be live, it lets you kind of look at what you're doing as you're doing it. And if something just doesn't seem right, with the proportions of the connecting elements or the members, it makes it a little easier to key in on what aspect of the design may need to be changed. Down below the diagram, you can see download typical detail for this connection, and there are a couple links there for the PDF and for the CAD formats. And so again, just if you do run through the connection, you say, okay, this works, this is what I want to put on my project. With a click, you'll have the file, and you can just go ahead and essentially copy and paste that onto your drawings with some project-specific edits, of course. Looking down, starting to get into the specifics, I'm highlighting the bolts input section here, but a lot of these points are really applicable to any of the input sections. Of course, you can change the number, bolts, the size, the grade. Generally, I think engineers are familiar with what thread condition is and how that affects capacity. But if you get to a part of the calculation which you're not familiar with, so for example, let's say the engineer isn't familiar with the concept of allowing bolt hole deformation and how that might affect things, every single one of these parameters has a drop-down. And so in that drop-down, you're going to find a direct description of what that particular parameter is and how it affects the result of the calculation. But then crucially, we also have, for every single line, an AASC, well, in this case, AASC, a code reference. Again, will be Canadian in some cases in the future, but a code reference so that if you want more information, more background, where you really want to dig into it, for any reason, you know exactly what to turn into in the manual to get that information. As you would scroll down, there's a lot more content there, and here's a shot of that on the left. Again, I'm in the detailed view here, so everything is visible. If we clicked into column properties, for example, we would get the wall thickness and the height and the width and the constant J for torsion, etc., etc. It's all there. It's all visible, just in case it needs to be referenced. Above that, you have the loads. And of course, we can enter some new loads. So if you go to that edit button where it shows the load magnitude, in this case, of course, we're doing a shear connection, so it's just a vertical load. If you were doing a moment connection, you would have a space for shear and then also for the moment. One of the pieces of feedback we've already received, which we are working on, is getting axial load into these beam calculators. So that's not quite there yet, but it certainly will be a feature that is coming in the future. But basically, once you go ahead and enter these loads, you'll see over here we have the original loads and the utilizations. As soon as you enter those, you're going to see all the utilizations change. So you don't have to run it in some way. It's all live. Now again, we've got a lot of lines here. Some of them are just the ones that say properties are generally just giving you the information of what the various parameters are. Then below that, we have a pretty large section of different checks that are being run. So those are the bottom 6 categories here. You've got the load combinations and then all various limit states. And so again, those are all going to have code references on them. And if you want to jump in to see, for example, in this case, where that 48% is coming from on the column, you can drop that down and it's going to break down, what are the various checks that are being run. So for example, in this case, we've got 2. One is going to be an actual kind of demand capacity check that's giving you that percentage. And there's also a slenderness check to make sure that the column meets the requirements for this type of connection. If we were to look at the bolt capacity dropdown, that one would probably have 3 or 4 different limit states, bolt shear, slip if that's relevant to your connection, etc., etc. And again, in keeping with this idea that everything is transparent and we don't want to have any black boxes and we want to make sure you know exactly where to get more information, if there's something you're not familiar with, so for example, here we're talking about punching shear of an HSS column, you can just click on it and again, you get that description. What is it? Where can I find information about it? What's the equation, etc. So just trying to make it as transparent as possible and make sure that there's nothing that's ambiguous where the numbers are coming from. And that's true both of the calculators themselves and then also the reports that would be generated subsequently. So there's the equation and the reference. So with that, if you've done the connection, you've gotten it to where you want it to be in terms of adequate capacity for your application, you're ready to document it for submission to whoever needs to look at it. You can go ahead and up in the top right, you have that printer button that's going to generate ports. When you hit that, you're going to get this interface pop up. One thing I do want to note, currently there are 2 checkboxes on there for member schedule and project defaults. In general, I would suggest to leave those unchecked. Those are associated with the base platform. They're not really applicable to a specific connection calculations, and those checkboxes will probably go away in the future. But for the moment, it's not a problem if you check them, but some information is going to go in there that's not really relevant to the connection. So I would leave those out. When you go up to the print mode, we have a few different versions of the report, basically just how much depth you want to go into. Again, 1-page summary, self-explanatory, standard, where it's kind of the highlights, and then detailed, where it shows every single number. Naturally, if you choose one of the more abbreviated versions, the reviewer will probably ask you where the other information is, and if you choose the detailed one, they'll complain that the calculation report is too long, but that, alas, we don't quite have a solution for. So once you're ready, you've got everything set, you've chosen your connection, and of course, as you see, you can do a whole group of connections at once if you'd like. You can go ahead, hit the export button, and that'll produce the PDF. There is an Excel format as well. The Excel format is not going to be line by line run through of a specific calculation, but if you want to see all of the calculations you have with the demand capacity ratios, you can do that in Excel as well. Before we move on, one other thing I do want to point out, Over here on the right, if you can see my cursor, there's a little paper airplane, and that is how you get in touch with us. So if you have anything you want to tell us, whether there's a way that you think we could make the calculations clearer, or if you have a question about how something is working, go ahead, hit that paper airplane, send us a message. It's going to come straight to the engineering team, and we'll make sure to get you an answer as quickly as possible. Questions, feedback, everything is welcome. We want to be a resource, and we want to hear from you guys. So once you press that export button, this is what the report is going to look like. Of course, your firm's logo will be up here instead of my snarky, but it includes all the basic information you'd expect. You've got a sketch of the connection. Again, this is going to be a live representative sketch. It's not just conceptual, so it'll be all to scale to let you see that it looks properly proportioned. And then you have, of course, your loads, your governing load case, and the overall capacity ratios. So should have put these highlights on there. One other thing to note is you do have, again, the button here for the typical details. That is a hyperlink within the PDF, so you can access those typical details that way as well. Again, just trying to make them as easy to get to as possible. And all the information there, the general stuff at the bottom. As you go through the report in more detail, of course, it's going to get into the nitty-gritty. Again, I did do this as a detailed report. Some of this information, for example, especially the stuff at the bottom, the column grade and the design wall thickness, that may not be shown if you're looking at the standard view. But again, detailed, it has everything. And again, all of these lines come with the reference in the steel manual or in the spec where you can look for more information. After you get through that, got the table of all the load combinations, as well as the line-by-line limit state checks. So, and again, with all of the references here. So there's one maybe notable difference is, whereas in the calculation itself, I can click on any line and get a description. That's not here just because to include that in the report would make it comically long. So if you do want to go back and see a description, you would want to go to the connection itself to click on that line and just see how that math is being done. So that's really, that's the interface. It's not really groundbreaking in the sense of, how you go about inputting the information and getting the answer, but it is a big deal for HSS design because, of course, the existing software out there doesn't really cover that topic in nearly the depth as wide flange is generally covered. Again, just because it's currently less common to use. So we think this is going to make a really dramatic difference in how engineers interact with HSS and are able to use it. In the center of this slide here, we have the calculators that are available currently. There should be 20 there, if my recollection is correct. And then on the right, we have coming soon. And so the only thing I want to highlight here is that coming soon does not mean, over the course of several years. We're moving very quickly to get these additional calculations and details out there so people can make use of them. And we expect to have be up to maybe about 70 connections in the next several months from the 20 that we're at now. So if there's a connection that you think would be useful, but you don't see it, please use that little paper airplane button. Send us a message. Tell us what you want to see. We absolutely do adjust our development pipeline based on the feedback we get. But know that that it is growing quickly, and that there's a good chance that if something's not here now, you will see it in the near future. So with that, we still have a decent amount of time, but I'm hoping to have some questions. I'm going to remove my presentation from full screen here so I can see the chat. The first one was whether it's possible to input factored loads or custom load combinations. So this is a question that has come up a number of times. I'm going to go ahead and jump over to the Connections Hub itself. So here we have a typical connection. This is a wide flange beam to HSS column shear connection. And the question has to do with
these loads that we're entering here. So currently, we can enter all the various load types from AESC 7. There's not yet a way to enter a pre-factored load, though that is a request that we've received a number of times, so it is on our development pipeline, so the feature will be added eventually. What I would suggest people do in the meantime, if you do have a situation where you only have the factored load, for example, I know this comes up with connections engineers when they get loads from the engineer of record, sometimes it'll already be factored. In that case, my suggestion would be to go ahead and select a dead load or really any of the loads on the list, and then just input the appropriately scaled down version. So for example, if the factored load you get from the engineer of record is 120 kips, you can just go ahead and enter 100 kips of dead load, and then of course, once the program factors it, the result will be 120 kips. Now in this case, of course, that's making everything fail because that would be an awful lot of load to put on this connection, but that would be the method that I would suggest using if you find yourself in that situation. And as I say, eventually that feature will come into the program. Okay, so the next question, let me go back and put this to a reasonable load number here, so we're not looking at a bunch of red.
Can you run through a brace connection?
So the brace connections are in the group of things that are currently under development, and that list that we had towards the end of the presentation there are, I believe, a couple brace connections. So I would expect to see them in the next couple months, the vast majority of which are beam connections. If we do this webinar again at a later date, we can run through a brace connection, but that is not quite available yet.
So the next question is, are there any calculations or details using hollow bolts? So again, not currently. Right now, all of the connections that we have that do require fastening from one side are done using Shuriken. That uses standard A325 and A490 bolts, which makes it a little bit easier from a calculator standpoint because we're pulling the numbers directly from the steel specification. With various proprietary fasteners such as hollow bolt or blind bolt, in those cases you would need to pull the fastener capacities from the manufacturer's table. So we are looking at that. We're not completely decided on whether it will be added as a feature, just because if the model of hollow bolt or any of these products were to change and the load were to change, we would need to make sure that we have a way of capturing that in the program to make sure we have the most updated values. With all that said, in general, for most of these calculations, you can still run the numbers for the calculation as a whole using the Connections Hub, and then at that point you would just want to pull out the bolt forces from the results and just check those against the load tables for those particular fasteners. Another thing that it could affect that you just want to be aware of is if you've got a connection that's governed by either net section rupture or block shear, then having a wider hole, as some of those other proprietary one-sided fasteners do, could affect the net section rupture or block shear capacity. Okay, next question. How do you control the member orientation? So this comes up in a few cases. In this case, of course, we have an HSS column and a wide flange beam. So when the column is what you're looking at, you can go ahead and if we change the size here from square to some kind of rectangle, so let's choose maybe a 16 by 8 by 3/8. At that point, once you've changed the size, an option for which connection face or which face you're connecting to comes up. And so right now we're connecting to the short face. So in other words, well, there's no moment here. If this were a moment connection, we'd be bending on the strong axis. If we switch to the long face, you can see the diagram changes, the scale changed slightly, but you can tell now that the beam is, the beam depth, which hasn't changed, is much larger compared to the column, and that's because we've flipped the column orientation. So the next question is, does the HSS Connections Hub check all of the limit states associated with the AISC code? And the answer there is yes. We've built this so that this is a complete calculator. that's going to go ahead and make all the checks that are required for any particular connection type. Now, of course, that doesn't mean that the engineer's judgment is not still an important part of the process, but there are no additional checks that need to be run after the fact to determine whether you've got an adequate connection. While these calculators do include all of the strength checks required by AISC 360, it is worth noting that depending on the characteristics of a given connection, there may be different stiffnesses. Those requirements are not very well defined in the AISC code, but they do have requirements for rigid versus partially rigid connections. And that is certainly something that an engineer needs to be aware of and use their judgment as appropriate. Okay, next question here. Will we be able to do a cat plate, moment plate, and bottom plate? And the answer there is yes. We will be adding a connection where the beam, generally wide flange beam, runs over the top of a column that has a cat plate. And that is relatively close on our development pipeline. So I would expect to see that calculation in the next few months because we know that is a relatively common condition. So the next question is, does your software address connections to round HSS? That is in the development pipeline. We actually have a few calculators that are completed and just undergoing QA that will allow you to select round columns. So we're going to start off mostly dealing with the shear connections. So for example, wide flange beam to a round HSS column. But we will also address moment connections. For example, if you have a moment connection to a round HSS column, a wraparound plate is a good solution in that case, and we're going to be adding that function as well. Also worth noting that we'll be including a complete selection of T, Y, K, and X connections. Basically the connections in chapter J of the chapter K of the specification, and those will all be available using round members. So if you're doing a truss made up of round HSS, we'll be able to calculate the capacities of the connections in that truss. The next question, pretty simple. Is there an option to choose between LRFD and ASD? And the answer is yes. It's actually right up at the top here before you get to even selecting the connection type. So it's kind of away from the member selections and the other properties. So easy to miss potentially, but yes, right at the top.
How extensive is the calculation printout? I think we did kind of cover that. If there's maybe a more specific item where you're wondering if it's included, we can look at that. But suffice to say, if you're choosing the detail calculation setting, it's going to include every single number that goes into the calculation.
So that kind of wraps up the questions that we got on this webinar. But as you use the program, of course, we understand that more questions will probably come up. So just a reminder that over here on the right side of the interface, there's a little paper airplane. If you click that, you can get in touch with us directly. So hub@atlastube.com. We make a point of trying to answer all those inquiries as quickly as possible, generally within a few hours, even if just to say we've got to look into it further. So we do want to hear from you. Appreciate you taking the time to learn a little bit more about the Hub, and we hope that it helps you out in your work.